Okay, everyone, I'm sharing my screen. Uh, where's my Zoom? Wait, stop share. Uh, Remote desktop share. Okay, yeah, let me know once you see, once everyone is able to see my screen.
Yes, we can see your screen. Yeah.
Great, perfect. So, okay, so first of all, let me give you my introduction. My name is Samir, and I will be taking your Cisco ACI training. Uh, and we will go through all the syllabus and everything in this class as well as in upcoming classes. So I will be throughout this training session. And one second. Uh, and about myself, like I have 10 years of experience working in data center technologies, like Nexus, core devices, load balancers, Palo Altos, firewalls, Cisco ASA, checkpoints, and Cisco ACI. I have been working on Cisco ACI for last like 5 6 years. I have been working, and I have experience working in like different domains, also like different of like fintechs, medical industries and BPOs and service industries. So I have like different experience working on different data center technologies throughout all these 10 years. And so that's all about myself. So I would like you, someone from who has joined today, to introduce themselves and also let us know what are your expectations from Cisco ACI so that I can accordingly give you today's lecture. So anyone wants to go
Okay. Yeah.
first?
Yeah. My name is Shamsher. So basically, I'm from Delhi. So I have 10 years of experience in routing, switching, and firewall. Okay. And currently, I'm working with HCL Tech and working with the US project. Okay. That is the insurance, US insurance company. And I want to learn ACI technology, and that's why I joined this institute.
Yep, perfect. Thank you, Samshir. Anyone else? Anyone?
Hey Siddharth here. I'm working with a tech system. Usually working on the data center. So I'm really more interested in the ACI technology to know.
Yep,
Again,
perfect.
routing and switching only. So I
Okay.
also deep dive in the ACI technology as well.
Yes, definitely, Siddharth. We will cover all the syllabus as per our exam topics. And after this, you will have a very good grasp on the Cisco ACI concepts and terminology. Okay, great. Anyone else?
Thanks.
Anyone else want to go? Shall I start?
Yeah, we can start.
Okay, great. So, I just wanted to understand the audience that I have today. Okay, and I'll assume that at some level you are all like very familiar or been working in the networking domain. Okay, be it like at least routing switching. So that's a good start. And here is the syllabus that I'll be covering. You can find this on Network Journey website. So the one that we will be covering here is implementing Cisco application centric infrastructure. Okay, the exam code is 300 620. Okay, this is the exam code of Cisco.
Mm-hmm.
So if you are aware, like the Cisco's architecture right now with classes with this is like, they have CCNP written. Okay, that will be your core exam. After core, we call it a core exam. Okay, that like this is the mandatory something that you have to take. And then there will be like specialization. Okay, and that specialization is like, there are a couple of tracks that you can take in Cisco. Out of those track, one of the track is this 300 620. There are other tracks also like Nexus and Advanced ACI and other stuff. So to get your CCNP certified, to have a CCNP data center certified, you need to take first of all the core exam, and then the second exam will be, the second that you need to do is you need to take the specialization exam of any one of the track. There are like, I guess there are like 5 to 6 tracks. So any one,
Mm-hmm.
if you take, you will earn a CCNP. And even if like you do not give the core exam, if you go with the directly Cisco ACI this exam, that is also something Cisco has provided flexibility. You can take this exam, and you will be getting a CCNP specialist in this exam, Cisco ACI. So like anyway, if you see, this is a win-win situation for you. It's
So
really great.
directly we can do this certification, right?
Yeah, yeah, yes, you can directly
So
apply for this
CCNA
certification.
CCNA is also required to do this,
No,
or
no, no, no. CCNA is not required. You
Mhm.
can you don't need to first get CCNA, then CCNP, and then CCI.
Mhm.
That actually is not the scenario here. So if it's
Okay.
yeah, it doesn't matter if you take CCNA or not. If you have a CCN,
No,
uh,
done CCNA, but that is
mhm.
expired. That's why
Yeah,
I'm
yeah,
asking.
no, no. So, yeah, so like the thing is that if before expiry of the CCNA, if you take any of the CCNP exam, which is like higher exam than the CCNA, you actually renew your CCNA exam, you know?
Ah, that, yeah, that is I know. But
Yeah, so
done CCNP also switching, but that is also expired. So
okay, yeah.
can I do directly ACI?
Yeah, yes, definitely. You can book a voucher from say Pearson, Cisco website, and take the Pearson exam for this 300 620 directly, and you will earn a CCNP data center specialist. You'll not be a CCNP data center, but you will be a
Mhm.
CCNP ACI specialist. This track is called specialist track. Okay. So
Okay.
yeah, that's all right. If you take the exam, that's
Mm-hmm.
perfectly fine. You can do that. Okay.
Mm-hmm.
So now if I come to implementing Cisco so this is the basic layout. This is as per this exam. Okay. You can find this on the Cisco website also. This is in public domain. Yeah, all the topics that the exam covers.
Mm-hmm.
Now, first of all, is ACI Fabric infrastructure. Okay, like describe ACI topology, hardware, ACI object model, faults, event
Uh,
record, audit log.
one thing, Samir, before
Yes, yes,
starting
I'm sure.
this, okay. So, what are the basic required to complete this course? Like, we need to have understanding like Nexus, or what are the basic required for this?
Uh, so I think Shamshir, you already like you're working and in like data center like network, right?
No,
So
data center I have worked, but not in ACI. Okay, so
yeah,
worked
yeah,
on
I'm coming to that.
Nexus.
Yes,
Yeah, worked on
correct.
Nexus.
Correct, correct. So, see, in Cisco ACI, the underlying the hardware we are using is Cisco Nexus 9Ks only. Okay,
Mm-hmm.
but the hardware part is not that much. Once we are covered with we will cover it in first lecture. Okay, the
Mm-hmm.
hardware, the requirement, how it is different with the other NXOS. Okay, what
Mm-hmm.
is the difference with ACI? That is all that you need to have information. The rest of the thing, So see, this is an application. This is an ACI. This is a software defined network. This is a
Mm-hmm.
software defined SDN solution from Cisco, right?
Mm-hmm.
So that is the beauty of this product is that you need to know the flow, like how you want to deploy a application or a server or port or any device, right? You need to know the flow and everything you will do it from the GUI. You don't need to go into the CLI, so everything you
And
will do from the GUI.
GI.
So
And
yeah, so
that
there
is
is
for the application only, right?
no, like there's application is one part,
Mm.
but there's a like holistic picture that I will give to you in coming few minutes. Okay.
Okay, okay, okay.
Yeah, so there is like no basic requirement even if you are not aware of network, Nexus and all. I will we will go through it. So you need I will teach you the ACI infrastructure, the Nexus, how we deploy, how we what is their flow, what is the traffic flow, everything, all this that is covered in this topics, right? So there
Mm.
is no like prerequisite. If you are good with routing switching only, that is also fine. So there's no prerequisite, like basic understanding of network is also fine. And in any way, if you have any questions, like I'll be there so to answer your doubts. Okay. So coming
Okay,
to
fine.
this, yeah, coming to this, like ACI policies, access, fabric, we have logical construct. These are very, very important. Tenant, application profile, VRF, bridge domain, endpoint group contracts. You can say this is like the, the logical construct of the fabric, and it is very, very important. So this is little bit, not like conventional VRF, not like conventional SVIs or L3 VLAN. We do the same things here, but since it's a software defined, there are different namings are there. So once I take you through all of them, you will be very comfortable and you will know exactly what is what. Okay. Then ACI packet forwarding, as I told you that, because in ACI Fabric, we have endpoint learnings, we have devices connected, unicast routing, layer 2 unknown hardware proxy, all these things we will learn. Then external network connectivity, because we need external connectivity from any like network. We need to connect to internet, we need to connect to MPLS, whatever external. So we will see layer 2 out, we will see layer 3 out. Then integration is that we will see the VMware integration. So VMware DVS integration, virtual switch, and we will the service graph. So this all integration we will see. Then ACI management for basic out of band, inbound, syslog, okay, AAA, and finally ACI multi-pod, multi-site. We will see about this architecture. What is this architecture and how it is configured? Okay. So this is like the basic overlay of what we will be teaching in this lecture. Now Uh, let me start my session.
And Samir, will be covering VXLAN also in this session?
VXLAN will for VXLAN, I will touch base a little bit on VXLAN, but like for just for the ACI part, uh, that we need to understand for the ACI. So we will touch a little bit of ACI VXLAN also, because in the background everything is running on VXLAN.
Okay.
Do you see my screen?
Yeah, yeah, we can see.
Do you see this whiteboard?
No,
No, no, your name only. I mean,
I think you are not sharing.
Oh, okay, okay. Hold on, let me share. Uh, Share whiteboard.
yeah, now we can see.
Perfect. So, Okay. One second. Border leaf architecture. Yeah. Okay. So today we are going to cover Cisco ACI, right? ACI stand for Application Centric Infrastructure. So have you noticed it's called application centric. It's not called network centric, correct? Why? So the question that should come to my mind is why it like how it is application centric because we are using Nexus switches, right? So Cisco ACI is an application centric infrastructure solution, right? So nowadays, if you know that you know there are a lot of SDN solutions which are coming in the market, right? Because we are moving from our traditional network towards software defined network, right? So there are many advantages of software defined network, SDN. The underlying connectivity will always be network, but we are making our network infrastructure more aware of the application, right? So what used to happen previously was, let me draw. So what used to happen earlier was that I am a network engineer. Yeah. I'm a network engineer. This is my route. This is my switch. Let's say this is my router. This is my switch. Okay, this is my like core, and this is my stuff. So earlier, what used to happen is that I am a network engineer. This is my access layer. Okay, I'm always I am tasked to okay. This is my user, and you know this is some application is coming from internet, and here it's my server is connected, right? And uh, all network engineer was like we used to configure each and everything here, and network guy was not really in like aware, or I would say we really don't did not care like what application was working, right? So there might be some application. So I'll take a real life example. Let's say Netflix is there, right? So if you talk about, so in the cloud there is some Netflix, okay? There is a user here who has downloaded a, a mobile application for Netflix, okay? And some new movie or something comes up. So I'm browsing the Netflix, okay? Netflix is sending the request back to my data center. This is my data center, right? This is my data center. So Netflix traffic is coming back to me, and it comes on my router, it comes to my core access switches, and finally to wherever that movie was. Let's say this is a database server. Here my data application or my actual movie is residing. So my traffic flow would be like how? It will be like this, right? It will be like this. So from network engineer perspective, we were not very concerned with what application like Netflix is there, like Facebook is there, or Twitter X is there. We did not care about that. What we care about is that this is my router, this is my IP addresses, okay, this is my configuration, everything. Okay, if my connectivity is good, everything is up, everything is good, right? But what happens is that the business runs on the business is running on this application, right? Netflix. It's not running on network. Network is the infrastructure that supports the business. The business actual business is Netflix. So what happens if, let's say, my Netflix on Netflix, I suddenly there are multiple releases or multiple movies being released every, or there are, let's say, a cricket match is being telecast live. What will happen? I have thousands and thousands and lakhs of maybe if it's matches, international match, maybe final matches, it will be above lakhs of users coming in. So the application will face a lot of strain, and this application has to cope up, or this application has to run in sync with the application, correct? So it has to our network has to be aware of what's happening in the happening in the real application. We have to cater to the application. So to bring this model into practical use, we right now, if you see, everyone is moving to SDN. So this is just example of Netflix, but right now in market, if you see, SDN solutions are everywhere. That is software defined network, and this is like the future of networking, because we want our network to be smart. We want our network to be aware, not just till the L3 level, till the network level, but at the L4, L5, L6 level also. So that's why we have bought software defined network. So there are multiple solutions in the market. Like if you say for computing, where's my 1 second. uh, 1 second, guys. So, guys, I hope that is so everyone, I hope that is clear. Like, what is the need of software-defined network, right? Now, moving into like other software-defined network, what are the benefits of software-defined network? Okay, let's talk about that. So, first of all, software network, like the benefit is we have a centralized controller. Okay, we have a centralized controller. So we have one controller, okay, that will you don't have multiple controllers that are managing the devices and everything. You have a centralized controller, and that centralized controller will be taking care of everything, right? Next, we what is the benefit? Like this is software defined, so definitely if it's a software defined, it can be programmed, right? Then we have separation of control and data plane. So control plane will be somewhere which is control, which will be taking decision control and everything, and data well plane will be where actual data will be handled. So we have a clear separation of control and data plane. Then this solution is less expensive. That is why one of the reason is that in market expand in the market, you will see nowadays a lot of SDN solutions, like everything. This can integrate with applications. Okay, that is like our main goal why we are bringing software-defined network. So talking about software-defined network, we have different solutions. Like if I talk about data center. In data center, I'll be able to see like there is Cisco ACI from Cisco, then from VMware we have NSX. Then we have if we talk about the WAN, okay, WAN side. In WAN we have SD-WAN from Cisco, that is Cisco Viptela, Versa, right? Velo Cloud. What are these? These are all SDN solutions for WAN, for connecting our edge routers, devices, networks to our hub headquarter, right? This is again software defined. Then for branches, we have the solution branches. We have solutions like Cisco DNA, right? Cisco SD access. So these are few of the solutions in the market that you will see which are leveraging SDN, and these are all solutions based on software defined network. Now coming to the challenges that we face with traditional network and the uh, yeah, let's talk about the traditional network. Okay, so I will say traditional network. Okay, so anyone tell me a couple of points of what are the challenges that we face in traditional network? Anyone?
No, it is not centralized.
Yes, good point. Not centralized. Next.
Not zero touch provisioning.
Yes, you're absolutely right. What is the zero touch provisioning? So I would say
It
management, right?
management. Yeah.
Yeah. So zero touch provisioning is means that you just need to bring let's just say I have a client, right? This is my client, and this is I'm talking about SD-WAN. That's like the very easy, like most easy relatable example. So I have a client here, and this is my data center. Okay, this is my data center. This is my hub router here in data center, right? This is somewhere in cloud. In the client At the client level, what happens is that this is a new client that I want to onboard. Okay, let's say this client is Geo, right? And let's just say that this client that I want to onboard, Geo has a very remote branch. Remote branch is like let's say a very small town in India, somewhere in let's say Maharashtra, somewhere in let's say Nagpur. Okay, he has a very small site, like couple of users or a small branch office for Nagpur location. Now I want to like, and I am managing this all whole infrastructure, let's say from Bangalore, right? So it will be really difficult. Like what we used to do is take the router, take the local console, configure the interfaces, then bring them up, and connect a connection and everything. So right now, this all using ZTP, zero touch provisioning, means that you don't need to really care about where your device is and how. You just need someone to plug this device to maybe let's say internet. Okay, once it's connected to my internet, okay, what would this device will do is this device will connect to back to my vendor. Let's just say this was Versa, right? Versa SD-WAN. So it will connect to Versa. This device does not know anything about my data center, my anything, right? So it will connect here. Then Versa will register this device, and it will direct me to the my router. And my router will, once it is my data center, Versa will say, okay, now your provision. I don't care about you. You are now connected. So and once it is connected here, my whole configuration, everything will be pushed automatically to this device. What I did, I just connected my internet cable, that's all. Everything else was taken care after this. So that's a part of zero touch provisioning, right? So yeah, that's a good point. Management. Any other point? Cost of management, right?
Yeah,
Cost of
that
traditional
is the
network is high.
main point.
Then we have very less VLANs available here. Like, what are the maximum number of VLANs that we have in traditional network? Anyone? What is the maximum VLANs we can have in our traditional network?
I think it is 4096 something.
Yes, 4095. Yeah. But Yep, you're right. My finance is something. Yep, correct. That's the right answer. Then management. Then if we have to upgrade it, it's really a hassle, right? We have to manually upload the iOS and do all the reboot, Roman mode, everything. Agree?
Yeah.
Then this is not programmable. Can we program this?
No.
Right, there's very limited programming. Like there is script, like you can do event scripts and other stuff on Cisco router, but then again that is like really having constraint. There's not much of flexibility there, right? Then the major challenge is this. What is this?
STP.
Penalty
Yep,
protocol.
right, spanning tree protocol. Why this is the challenge? Anyone?
So I think it is like using equal cost multipath means multiple paths are not available. Like
Event loop.
Exactly. Bingo. Yes, right, you are right. So let's just say that this is my server. Okay, this is my Netflix server, right? Now this is a switch one, this is switch two, right? By default my STP is enabled, and what will happen is that STP will block, because there are two forwarding paths, right, from this server to this switch one, switch two. It will detect this loop via BPDU and it will block this link, right?
right.
So now what will, yeah, from STP, when the STP was created back in 19, 70s, 80s, it was thought of as, uh, a very good technology, right? At that time it was, but as the network grew larger day by day, it became kind of problematic for to use STP. And we all know, we are, as a network engineer, we are always afraid of layer 2 loop, right? That is the worst thing a network engineer can have a dream of, right? so uh, so let's say this is your 10 gig fiber, right? This is your 10 gig fiber, right? So you are paying lot of money. These are optical cable, these are costly cables, right? And at a time you are just running 10 gig, so you are wasting this whole 10 gig 10 gig circuit, 10 gig link. You are wasting this capability. This is wastage in money wise, like the cost you have put in here, there is no ROI. You are wasting that money. Then again you are wasting the redundancy, you are wasting the, as a part, like, uh, as a part of bandwidth, you could have used 10 gig 10 gig and multiplied your bandwidth, but this is again going waste, right? So that is that was the, like, the major problem with STP. So you would say that, okay, Samir, I can just uh, do a port channel and bundle this, correct? Right,
Mm-hmm.
guys? Yeah.
Yes, yes.
Yeah, but again, there is a limitation on the number of port channels you can have in traditional network, right?
Right.
There is a certain number of, like, I think it's 16 something,
Yeah.
the maximum link you can put into a port channel. So again, there are limitation, and then configuration wise also it becomes really somewhat hectic. So that's one of the challenges of the STP. So I'll come back to that. Then again, what's the next point? Centralized model we created, okay, not centralized, and this model is blacklisted. Okay, what does mean? What do you mean by blacklist? It means everything is allowed on a switch until unless you have pulled in some ACL or something.
Mm. Yes.
uh, you're able to communicate to each other, right? Everything is allowed basically. So from security perspective, that is not, like, if you're in security and you say, oh, my network, everyone is talking with everyone, so that is a red flag, right? You don't want everything to talk with everyone. That will be a nightmare for network security auditing and everything, right? So to overcome this model, Cisco came with Cisco ACI. Okay. Now interesting fact here, Cisco ACI is also like, Cisco actually purchased or acquired one of the company. I am not recalling exactly the name of the company, but that company basically was into software defined like data center, and info something, that company name was this. You can check it as a homework. So after Cisco bought this company, they have, because Cisco is already into data center domain. We have from UCS servers, we have Cisco firewall, we have Cisco load balancer, we have Cisco switches, core switches, Nexus, you name everything, we have Cisco, right? So Cisco modified that the product, and it came in the market with the name of Cisco ACI. So the benefits of Cisco ACI here is that, first of all, it's a SDN model, and the benefit of SDN model is that this is centralized. So what does centralized mean?
Centralized means we can manage all the things by controller.
Correct, right. So here in this architecture, you had to go into each and every switch. Let's say if I tell you, okay, Samshir or one of our network engineer, I want a VLAN change on this server and anything, or let's say there are multiple switches are there. I have bundled 16 port channel with 16 different switches for, let's say, redundancy, and I said, okay, oh, you know what? I need to allow a VLAN on all those 16 interfaces. You need to log into each of these switches and do that configuration. That will be a lot of, a lot of overwork for a network engineer, for infrastructure guy. That will be like too much to ask. So then, what happen? What happens in what happens in let me delete this. What happens in centralized model is that there will be one controller. Okay, there will be, let's just say example, this is a controller, right? This controller will be managing all all the devices that are in the fabric, right? So that's called centralized control. You don't need to actually come to all these devices. You need to push a configuration. You create a template. You push it from here, and it will be directly pushed to everything. Right? That is called a centralized model. Now coming to the next part, that is second, scalable. Our Since this is centralized, I can scale it up, right? I can scale it very easily. I can, I can connect multiple switches. Let's say I have to connect one more switch. I can do that because all the control is from central or from the controller. I just need to come here, provision this, and I'm good to go in my network, right? So it is more easily scalable than our traditional network. Uh, then this is mostly plug and play, because since we have a controller which knows about those devices, templates, everything. We can just plug it, and then we are good to go. Then we can do automation. Okay, automation of the network processes, NW processes. We can automate this. We can automate this because this is a software defined network. So we can automate this as per our requirement, as per whatever the need of the application or the business is. Then ACI is app centric. So in the starting I discussed what is app centric, right? So my network is aware about app, right? Let me come here. So how many layers in the OSI we have?
7.
Right. One, two, three, four, five, six, seven. Right. So application presentation and all that, data link networks, right? So
Mm.
at level three, this is my boundary, right? With network and with the this I would say is app aware, app level, right? This is
Mm.
more intelligent one, and this is like network. Okay, I at network I don't care. I just like know about my IP address, maybe TCP UDP, and I just forward it. Okay, but I want I want a solution that is app centric. It means that my network, my network is aware of the applications. Okay. So at level 7, let's say it's running Netflix or it's running Meta or XYZ application, right? My network is aware and it takes smart decision based on this application of what to do at network level, right? This would be my app centric. I want everything to be apps. I'll come to that why we need an app centric. For now, I'll just say app centric. Next, we have a reduce workload because everything is this. Next thing is no STP. This is the major change. In ACI, in Cisco ACI, we do not have STP. There is no spanning tree protocol running. Okay, all our ACI fabric is a slash 32, right? It's a point to point. We do not have any spanning tree protocol running in our ACI infrastructure. Since we do not have spanning tree protocol, if there are two links, if there are two links from let's say one controller, so I can use both of them. I can use both of them. I can utilize both of them. I don't need to worry about uh, you know wastage of my investment. I don't have to worry about the bandwidth, bandwidth constraint and other stuff because there's no STP. Like this is a major shift. Then from monitoring and troubleshooting also, it becomes very easy in SDN ACI. Why? Because in traditional network, let's say if a switch goes down, you have to trace it, right? There was You will have to log into your devices. You have to see where maybe trace is getting died. You are not able to ping your monitoring tool, SolarWinds or something will tell you that this is down, this is something like that. But in ACI, since ACI is centralized, it knows about the whole fabric. Okay, why am I repeating fabric? I'll just come to that also. So it knows about everything that is running inside its fabric, wherever the ACI is. So if it knows about the fabric, it knows it is monitoring it, and it becomes more easy for us to troubleshoot because ACI will tell you, okay, Samir, on switch leaf 101, your CPUs are getting really high, and one of your SFP is getting high utilized, so you better check this out, right? So this all I can just go to ACI and I can check the health scores. I can check, okay, are my devices in the fabric doing good or not? Everything, right? So this is like basic comparison of traditional network and ACI. Uh, Now I'll come to more traditional approach of three-tier architecture. Is everyone aware of what is three-tier architecture?
Yeah, distribution access and sorry, core distribution access.
Perfect, perfect. So three-tier architecture means like we had a core, right? Then we had distribution and we have access, right?
Yeah.
This was our three-tier architecture. The problem with this, do you see any problem? First of all, let's say, do you see any problem with this structure? Any suggestion, anything?
Yes, if distribution goes down, then it will be
Yep, perfectly. That's right. If distribution goes down, your core and access is just isolated. They don't know what's happening. There's a P1 bridge, and your senior IT, your senior director in IT, they're shouting, "Why? How did this happen?" Right? So, uh, tier three architecture, your users, their system, everything is connected to access layer, right? Then we have the traffic goes to distribution and then core. This type of traffic is called a north to south or south to north traffic. See, this structure was is actually real good for small campus and stuff. But when we are talking about data center, this architecture creates a lot of problem because let's just say that and we have this single link. Like let's just say I connected multiple access switches here, right? And to all those access switches, I'm using let's say 48 ports, or maybe I'm using a multi-chassis switch here, and I am connecting a lot of servers. Now all that traffic will come here to distribution, right? But see, we have from distribution to core, we have limited bandwidth, right? This is our bottleneck. There's a certain amount of, there will be always a certain amount of expansion that you can do here, right? Then let's say from this core, I from this server, okay, this is my Netflix data server, right? DB. This want to reach out to some application, Netflix application that is residing in, let's say, some other location. Let's just say some other distribution that is connected. So you see, it has to travel a lot of hops. First, it will come to access layer, then it will go to distribution layer, hop one, then this will be core, hop two, then this will come to another distribution, hop three. So the larger your number of hops are, the more latency it will accumulate, right? And also, it will also mean that there are more parts in the system that can fail, correct? The less number of devices in between my source and destination, the faster it is, more resilient it is, because I don't have to care about, okay, this is down, this is up, there's some issue on this one, because I know only one thing is connected. Okay, I'll come to that. So this was a three-tier architecture which does not fit very good with our data center. So how did we solve that problem? We simply bought something we call as two-tier architecture, right? What is a two-tier architecture? You also like there's a second name for this, that is clause topology. So this was actually invented by Charles Claus. So on his name, it is named as clause topology. Okay. What happens in two tier architecture? So let's say this is my spine. This is my switch. This is my switch. Okay. And this is my access switches. Okay. This is my, let's say, access switches, and this is my access switches. So this is also called as collapsed core. Okay, because here core and distribution, they are both at the same level. You don't see this distribution layer separately. So this is also called collapsed core distribution layer. And you have access switches. And in cross topology, we have the rule is that it's everything is connected with everything. All If this is a switch, this will connect to all the spine or the core switches. We call is spine. Okay, and in fabric we call it as leaf. The access layer level. So this is just a naming. When I say leaf, it means access switch access layer, and when I say spine, it means the core layer. Okay, so access the leaves, all leaves will connect to everything. Okay, this is a mesh architecture. In case this fails, this will take over. So you will have full redundancy. Also, this is the best technology that you'll have for east to west traffic. Okay. In data center, we have a lot of traffic that is going east to west. Within data center, we have like a lot of traffic that is going from east to west, because this is the traffic that is between database, between application developers developing their tools, testing and everything. So within data center, a lot of traffic is getting generated, and we want that traffic to travel with minimum latency and minimum hops. So this cross topology was the answer. So here everything is one hop away. Okay. So if I have to reach this switch 2, all have like whichever spine I choose, I just have to go this is my first hop and I reach the destination, right? So that's why it's called one hop architecture also. Everything is just one hop away. And this is the structure that we are using in Cisco ACI. Cisco Fabric.
Um, this
Also,
topology, can you
yeah,
hear me?
yep, I can hear you. Go ahead.
Yeah, but for this kind of topology, all I'm saying is too much cable, right? So if we have a lot of access switches, I'm just seeing a lot of cables.
Okay, so
So, I mean,
go ahead.
kind of architecture will not be efficient for like when we have, let's say, 6 or even 10 access switches.
All right. So I'll talk about the hardware. Sorry. I I I did not get your name. How do you pronounce it?
Oh, just Sade.
Sorry, Alaviya, right?
Sade.
Adil. Okay, fine. So yeah, I'll come to that. Yes, you are right. So if you are connecting multiple access leaves, switches to spine, it will it will be a big mesh. Okay, but that is the beauty of Cisco ACI. We are we are using we are using some specialized hardwares on the spine that I'll talk about in 5 minutes. And there is a certain limit that we can provision, okay, depending upon the hardware that we are using. Okay, depending upon the fabric we have, like you can have 80 switches connected in a fabric which has just two spines. Okay, there if the spines are more advanced in hardware, you can have up to 200 access switches that you can connect. Okay, but if you do you connect or not, that's a different scenario. Okay, we will come to that also in upcoming lectures. Why, what we do, what is the
Oh,
architecture,
okay.
how
I
we do.
think
Go
it's
ahead.
because I joined late. So we're just talking about the kinds of traditional architecture we could have.
Yes, we are
Oh, okay,
talking the
okay.
differentiation, right? Okay, yeah.
Okay,
So
sorry, I joined late, so that's right.
okay, no problem. Yeah, I'll take that later. So that was the clause topology, right? Collapse core, and here we are deploying some what we call as ECMP, so equal cost multi paths. So all our paths are forwarding. There's no STP, nothing at all. Okay. Let me talk about some hardware. Okay, and why this is called Cisco ACI. Whenever we refer to Cisco ACI, we will call it as a Cisco ACI fabric. Okay. Now, why fabric? Because if you see, like, just imagine if you imagine a cloth. In cloth, there are multiple threads that are, interwoven with each other so tightly that almost all of like single thread is crossing each and every other thread at some point. So that is the reason I think they took the terminology fabric, and that's what we call it as Cisco ACI fabric. So whenever I'm referring to fabric, this you will that will mean this two-tier architecture where we have a spine, we have leaf. Okay. Now coming to hardware, let's talk about something about hardware. In hardware, we have, let's talk about Nexus hardware. So Nexus, we had 9000 series, right? In 9000 series, we have we have couple of models like we have uh 9500 models, we have 9300, and then we have 9200. So in Cisco ACI, the two model that you will be using is 9500 and 9300 only. Okay. Now, what differentiates this 9500 model and 9300 model with a normal Nexus operation and a ACI operation is their operating system. So there are two OS that comes with Nexus, that is NX and ACI OS. Okay. So if your device, your hardware is installed or you install it with ACI OS, then only it will be used in Cisco ACI. Else it is just an NXOS switch that will be connected outside the fabric, right? So you need to make sure that whatever device you connect, device you make ACI OS is installed on that. And then 9500 you will see you'll see only in spines. Okay. These are like the only hardware that you will use in spine. You'll never see it as a as a leaf. And 9300 we use it as only leaf, but there are few models which we do like have the capability to be used as spine. So you can say they have both, but mostly all the leaves will be 9300. Okay. Then other models that we have for Nexus is like we have the 7000 series,
Okay.
7700 series. Then we have the 6000 series. Then we
Hello.
have yeah, sorry, yeah, good.
Yeah, sorry, quick question.
Yep.
So, the 9500, let's say it has the NXOS,
Mhm.
it has issues with NXOS. Is it possible, like, to convert it to ACI or?
Yes, definitely. So yeah, so whenever you'll get this device, right? And let's just say, let's forget about ACI everything. I have this switch. Okay. I got this switch. This is a brand new 9500. Okay. Now it depends on me if I want to use this switch in ACI, then it has to have the ACI OS installed. If it's not, it's my responsibility first to get that installed in ACI OS. If I don't want to use it in ACI OS, I can just continue with NXOS. That's fine, right? So you have the options. Now I
Once
hope
you
I answered
convert
your
to
question.
ACI, can you convert it back? Do you know?
Yes, 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 yes. So this is
Oh,
OS, right? Yeah, this is OS. You can convert it back to anything. Like you configure it with an Nexus, but your business requirement changed and your team said, yeah, no, let's use it for ACI. Let's repurpose. You just flash it, install ACI OS, and then from the central controller, you just get it configured, right? So, yep, that is possible. Uh, Then we have 7000 series switches, 3000 switches, 2000, which we commonly call as fax, and then we have 1000 switches that are mostly virtual Nexus, right? Now let me show you about the hardware so that you are more comfortable with hardware. Now let me delete this. So let's okay, delete. So this is how your ACI fabric looks like. ACI not fabric, sorry, your ACI fabric Nexus switches look like. So you'll see 9500 series are modular chassis switches, right? They have 4 slot, 8 slot, 6 and 16 slot. When I say slot, it means that you see these are line cards that you can put. So this is the largest of the all, which is having 16. This is 8, this is 4, and this is like one Z's, right? So you will see 9500 only as the modular chassis. It looks something like this. Okay, it looks something like one second. Okay, so this is how your next 950 platform. This is a 8 module. You see 1, 2, 3, 4, 5, 6, 7, 8. So this is a 8 module chassis. You can put line cards ranging from 1, 10, 25, 40, 50, and up to 100 gigs. We have options available for copper, fiber. We have two supervisor modules. We have fan tray. We have fabric modules. So this is for fabric modules. You see what does a fabric module means? So see, these line cards are connected like on the chassis horizontally, right? But there has to be some connection in between all of them. How are they going to talk with each other, right? So for that, we are using fabric modules. These are like in the back side, you will see them like a vertical lines. Basically, they function as connector to all these line cards and supervisor modules. So they are like mean the backbone you can say of the module, right? Then we have the 9300 switches, which we call as fixed leaf switches. You will see them mostly in leaf, but there are some which you can configure as a spine, but 9300 you will see in only in leaf only. Then we have different modules like 9336C, 93180, 9332PQ. So all our first generation. So there are for Nexus 930 series and all. There are two types of generation, like first generation and second generation. You can think of it as like Apple 13 and Apple 14. So the last generation was all starting with P. The new generations are starting with E. So if you are in a data center that is using ACI from like couple of years back, you might see the PQ model, but they will soon be end of life, end of support, and they you'll have to upgrade it to the EX model, right? Which is more capable in handling and hardware wise, it's more better. Then we have Cisco UCS server, C220, M3, and M4. So why do we need Cisco UCS server? Okay, here comes the main part that I would like to talk about. So Cisco ACI is the central controller, right? We talked it is a central controller. But what is the central controller? What is the brain behind it? That is APIC, which is called Application Programmable Infrastructure Controller, right? APIC. So you can think of APIC as the brain of ACI fabric. This is the central controller. So APIC is the central controller. It is the brain of the ACI fabric. It knows where everything is. It knows how the endpoints, where what is connected, how the traffic is being transferred, what the health checks, monitoring, everything. Even the configuration you will do from the APIC. So APIC is the brain of the ACI fabric, and it's basically the APIC. This is an application that has to be installed on a Cisco UCS server. Okay, so this is a virtual machine. Like you create a virtual machine. This is a virtual machine where you install this software called APIC, and it is installed on the bare metal. Do you know what's the bare metal, everyone? Hello, can anyone tell me
Well, like
about bare metal?
hypervisor.
Yes, so bare metal is a server which is which is hosting a dedicated application. Okay, there are not multiple VMs but dedicated application, so we call it as a bare metal. Okay, if you use multiple, then it becomes a hypervisor, right? So this UCS server, it will host the APIC application, and our APIC application will control all the ACI fabric. So how my ACI fabric looks like, let me show you. This is my ACI fabric. After this, I'll show you a small lab of discovery of different switches, discovery of the switches in ACI fabric, right? So this is my ACI fabric. Are you all able to see my screen?
Yeah.
Are you all able to see my screen?
Yes, ma'am.
Okay, thanks for. So this is my spine. Okay, this is my spine. This will be like my core, which we call as spine. Then I have leaf switches, right? And here you will see the APIC server 1, 2, 3. So Cisco recommends that minimum we should have three APIC controllers. These are called APIC controllers in a ACI fabric. And this whole setup, the whole white portion that you see, it's called a ACI fabric, right? Anything connected outside to this is will be outside of ACI fabric, right? And there is also one more rule in ACI fabric. Each and every device, anything that you connect in an ACI fabric, that has to be connected to the leaf switches. If it's a server, if it's a user, if it's a firewall, if it's a load balancer, anything, you connect it to leaf switches. You do not connect anything on the spine except for the leaf. So spine basically means like they are there just to forward the traffic between the leaf and nothing more. You do not connect any end device except for a leaf to the spine. Okay. This is like a very fundamental rule that Cisco ACI fabric follows. Okay. Anything, any server, anything, any user, you just connect to here downside. Okay. Nothing gets connected to spine. No, that's a bad design. You do not connect. You don't want any issues, right? So spine will be dedicated to connected to leaf, and that's how your traffic will forward and get done. Now today I'm going to show you about the discover about the ACI GUI and also how my fabric is discovered, right? So everything I do is from the APIC. I log into APIC, I provision, I monitor, I manage, I add, I delete. Everything I do is from APIC. And APIC needs to know where all these things are connected. So APIC will know the whole topology of the ACI fabric. It identifies, it discovers by using LLDP. There is this protocol that is running in the background. So using LLDP, so APIC will, let's say this is switch one. APIC will first identify this switch one. Okay. And as an administrator, I will have to allow it or deny it. Okay, in the ACI fabric. So I said, let's say, okay, I want to add one in the ACI fabric. Okay. Once that is done, then the there will be LLDP, packets that are flooding. So a LLDP packet will come from spine that will get forwarded to APIC, and APIC will know, okay, there is a spine also. Then we will onboard the spine. Spine will be onboarded on the ACI fabric. Once the spine is onboarded, then we will have the option to know, oh, okay, then the spine, because spine is connected to all the fabric. Each and every spine is connected to each and every leaf. So spine, APIC eventually will discover all these switches. Got it? This is how the discovery of ACI fabric happens. Now let me take you to the lab and I'll show you about the lab. 172.16.24. Okay, yep. Anyone has any questions till now? Oh, great. Everyone understood everything. That's fantastic. Can I get a response?
Yeah, it's okay.
Okay, thank you. So admin and password is not taking web. Oh, my caps is on. Cisco.
So we have this lab access, right?
Yes, you will get this lab access. This is the same lab that I'm doing, and let me log in. Yep, I'm in. Okay.
Is there
So
any
see,
server that we need to log in before going to the Epic
yes,
login?
this is a RDP. So once you are enrolled, and you will get the access to this lab from the network journey. They will provide you all the details. You can check with them. You will get the lab manuals. You will get the access to these servers. Okay, this remote. Then you will on the this remote we have the APIC and the Fabric running that you will use to do hands-on practice. Okay, whatever we will teach in the session, we will do a on-hands lab also of most of the labs that are possible because this is a lab. So what all the lab manual will be shared with you, and we will do practical on this epic. Okay.
Okay,
So
so
what's
completely
new in
GUI
yeah?
mode.
Sorry, go ahead.
Sorry. So this is completely GUI mode. So what about the hardware level? How we can understand that new installation for this UCS, that is for Epic, and Spine and Leaf 9500, 9300 switches.
Yeah. So great. So see, this is a virtual machine, right? This
Mhm.
is a virtual environment. Okay. There is no physical hardware here, which you can look into. But from the software part, the 9500 9300, we are going to onboard it into the API. You will be able to log into the devices. Okay, there will be login and everything. Everything will work as it is as you are doing a remote from some location to your data to your headquarter location, right? So
Mhm.
that all will be there. Okay. Hardware part, like this is a virtual environment, so hardware part will not be there because hardware.
Understood.
Yeah.
The question is like for practice, we need a simulator, right?
Yes. Yes.
So is it provided over here so that we can just connect one, two, three kind of leaves and switches?
Yes. Yes. That's what I'm going to show you. So
Okay.
all the lab will happen here only. APIC. Okay. I'll show you in 2 minutes. So this is the version 6.07e. Okay. Now this is a new setup, so it's asking me like start ACI Fabric setup. I can do that. It's a GUI wizard step by step, but I'll just say for now no. This is how your APIC looks like. Okay, this is your brain. Okay, system, tenant, fabric, virtual networking, all these tabs, everything has a meaning, right? This is your system health. This is your this is basically giving you all the details, everything. Okay, nodes. There are nodes connected here. Okay, nodes with health. Okay, these are my nodes. So I think this is from the previous session. So okay, so today I'm going to show you about the fabric discovery and how we onboard those devices in the APIC. The question that you asked, Siddharth, right?
Okay.
So we'll come to fabric. Okay, under inventory you go to fabric membership. Okay, now here is where you will see your leaf and spine connected. Okay, so this is leaf 101, this is spine 201. These are coming in registered nodes. So what do you mean by registered nodes? Like, it means that I already registered them in my previous session, so that's why
Um,
you're able to see this.
sorry to interrupt Samir again.
Yeah,
So
go on.
you are showing for the leaf and spine.
Yeah, yeah,
So
yes.
which one we need to install first? A pick or the spine or the leaf?
Yeah, so APIC will be pre-installed. APIC, yeah, your APIC will be pre-installed. It is running on a VM. So once the VM is up, there's this IP address that will provide it to you. You
Mhm.
once
Hey,
you log
Samir.
in. Yep, go ahead.
Samir, I have a question, right? Because I have a deeper technical question regarding the virtual ACI setup because we're using for the lab. Since we're working in a virtualized ACI environment, how would you be able to demonstrate the actual ACI fabric behavior? EP registration, endpoint registration through COP database, spine proxying function and VXLAN encapsulation and end-to-end packet flow. Basically showing us the packet flow on how ACI works, how when you bring up ACI, how it works, how it's registered to COP, how the VX encapsulation works. Are you going to go through all that in this course? Because I think it's very important.
Okay. Oh,
I
okay.
agree.
1 second.
And I think that's what this gentleman was getting to.
Correct, Josh. I agree with you.
Okay, yeah, sure. Yeah, let me answer that question. Wait. Mm, My lab just crashed. Oh no, my network. There's some issue with my network, and it's attempting to connect. Okay, so to answer your question, see, this is a virtual environment, right? We have the APICs running, we have the leaves, we have spine leaf, like everything is provisioned. We'll be able to make the changes on the APIC. We'll be able to, provision the endpoint groups here. Okay. Regarding the data, I think your question was more like the VXLAN flow and everything. Okay.
Yes, because it's important, right? Before you jump to this GUI and go through, it's like just skipping a step. We need to understand the architecture before you get to this point.
Yeah, right. So
And
for the VXLAN, I think, yeah. So for the VXLAN, I think you want to understand the VXLAN working, how the 64 bits are there, and how the VXLAN tunnels are built, and everything. I will
Exactly, like the endpoint
correct. I
registration,
understood.
right?
Yes,
How the endpoint registration is handled via
understood.
COP, how and EPG to EPG communication occurs to the fabric encapsulation,
Yes,
and,
yes.
and, and whether we'll be able to see a real packet walkthrough, right? Because I think it's important for this class that we do that part first, because then it'll just be a building block on top of everything else.
Right,
Don't you
right,
agree?
right. So Jose, right, Jose. So we are. I'm going to go into that theoretical part of.
Okay.
I'll touch like base with the VXLAN. I think for VXLAN, you can check with Network Journey if they're providing a separate, I think, full session on that part in more detail. This is like implementing Cisco ACI. There is advanced Cisco ACI. Okay. But there is like VXLAN also. You are right. I'll touch base on the VXLAN, how the VXLAN works. Okay. What is a VXLAN? What are the VTEPs? Okay. How the endpoints are registered? How the endpoints, what is the cube table? What is the MCP, miscabling protocols? Okay, how the traffic is how the traffic flow will be there. We need to understand that. You are right. In I think fourth or fifth lecture, we will have the flow of how the traffic flows, right? How at the leaf level, leaf once the packet arrives at the leaf interfacing guest interface, how it decides which path it will take based on what decision, there is this flow which I will show you different, which I will like take the theory of definitely. So we will cover that part as per the Cisco syllabus. Yes, and the endpoint groups, okay, the contracts that we will apply to the EPGs, the bridge domain. So these are all the topics that we will be covering in the upcoming lectures. So this is basic, very basic. I'm not taking those touching base on those advanced. I'm just giving you a ACI, what's ACI, why it is used, and this is like the best in data center right now running. So that all aspect I'm just taking right now. But yeah, that is very, very important. And in the syllabus, there is like, ACI packet flow, the constructs, bridge domain, endpoint groups, contracts, all will be there. So we are going to use this APIC. We are going to configure it from here. Okay, we are going to come to our, tenants. We are going to go in that tenant. We'll create the tenant, then we will uh, create the endpoint group. We'll create the BD. We'll understand the whole flow if that answers your question.
Yeah. I think that's important, to
Yep, yep. Yeah,
understand the
that is
packet
very
workflow.
important. Yes, because that is so the good part, I would say the beauty of ACI is all that VXLAN, all the MPBGP, all everything that is happening. This is a little bit advanced, but that is all happening in the background, right? You don't need to actually do those complex configuration because of this GUI. You need to know the flow and how it works. Yes, as a network engineer, we should always ask that question. Hey man, how this is working, right? What is the background? What is the backend? I need to have a clear idea of that from troubleshooting point of view, and I also need to know like how to configure it. right? So that I can achieve my goal of implementing, bringing up a new server, a new endpoint group, something like that, right? So, yep, that's what we will do.
Yeah,
So,
I have one more question. I put it in the chat, but I'll ask it here before you move forward, if possible. I know that we have a limited time. You touched on spanning tree, right? So I know that in ACI, even though spanning tree isn't used in a traditional sense, I've actually observed some cases where BPDU packets still cause issues or even take down the switch.
mhm.
Could you quickly discuss what might trigger that behavior and how best to prevent it in ACI?
So, Jose, I will have to, discuss about that scenario. But to answer your question, you do allow BPDU to travel your network in ACI Fabric, because you need to understand that uh, ACI Fabric is kind of a felicitator, right? Let's
Hmm.
say in your data center, like, in your data center, you have some setup in ACI Fabric, right? And out of that, I will talk about migration scenarios, right? You have a migration scenario, you are migrating to your ACI Fabric, right? Your
Hmm.
layer 3 is not at right now at your layer 3 or SCVIs are not yet migrated to the ACI Fabric. What are you going to do? You cannot, like, migrate everything at the same time, right? It's a big risk to business and everything. What if it does not work, right? You migrate. In any migration, you migrate step by step, right? In that migration, you will definitely, there will be a scenario when your legacy devices out of the fabric will need to have communication over other legacy devices, and your ACI fabric will be the felicitator, right? In those scenarios, what I can think right now, I am not exactly certain of what other scenarios you have like experience on, but most of them I have seen on deployment is that this is like common scenario. You'll need to enable BPDUs so that your legacy devices can talk to each other. You got my point?
Yep.
Yep.
Thank you.
Great. So now coming to nodes pending registration. So we'll just onboard. So since my APIC is connected to Fabric, it has detected one switch. This is a one switch 102 automatically, and it knows that it is waiting for, you know, registration. Okay. So all I need to do is, click here, right click and register. So this is like, to be honest with you, that is how easy it is to onboard a device, right? I just need to provide a node ID. I'll just say 102. I'll say this is a leaf 102. So ACI is very smart. It knows once it is connected, whatever device it is connected, it's a 9300 or 9500. It knows if it's a leaf role or it's a spine role. So it's giving me automatically, right? But then you'll ask me, like, there's spine option also. Why? Because there are some new this is like the latest version, and there are some new switches which can, as I told you, 9300, it can be as a leaf, or and it can be also as a spine, both role, right? So that's why it's giving me both options, right? So I will just click now, okay, leaf, register. When I click register, the status goes into unknown. After unknown, it will transition into active. Okay, so that's the next step. And once that is done, my node 102 will be coming up here. Okay, then I'll have a leaf, a spine, and one more leaf. So this will be your topology in your lab. APIC connected to leaf. Oh, see, it's here. It's right now unknown, but if I refresh it, it will become active at some point. So that's how this provisioning works. So inactive, and then it will go to active. This is the IP address. So APIC will automatically assign the IP addresses to the leaf, spine, whatever fabric device connects. The APIC will control the IP address assignment. It will assign automatically the IP. Okay, we just need to allow. We just define the DHCP pool, and using LLDP, it will discover, it will register, it will bring up the fabric, and once it's up, we will see all our nodes, registered nodes here. Okay, any pending registration we will see here. And if I see the topology, the logical topology, how it will look, then I can go here. Oh, so if I go here, topology, so this is my logical, this is my a short logical summary This is my APIC, which is connected to with my leaf. My leaf is connected to my spine, and my new leaf that just came up, it's somewhere here. Okay. So once that is all active, it will automatically come here. Right. See, it came here. Leaf 102, leaf 101. This is my ACI fabric. Okay. So this is how my this is all a small demo of what we will go through. Uh, I will stop at this point and I'll have like network journey go through all the details. Let me see if they are here. Okay. Do anyone has any questions?
Hey, Samir, are you going to stop for this today's session?
No, you have any questions for me?
No, just last things. Can you just repeat again? Onboarding for that leave.
Yes. Sorry, what was the last question?
Onboarding for that leave. Can you show it again?
Sure, sure. 1 second, I'll show you again. Yep. So in Fabric, you see my screen?
Yeah.
In Fabric membership, you come to nodes pending registration. You will see all the nodes that are pending to be added to the Fabric, right? You will
Okay.
right click it, you'll register it, and then it will come up here. Okay, once it is registered, you fill up few details, and that's all. Okay.
Okay. So IP
In the
address
backend,
you mentioned that is by default in the setup, or that we need to provide that, because I saw this IP address are unique for this ACI setup.
correct, correct.
And,
So yeah, so this is something. This is the IP pool. It's like a you know about DSCP pool,
yeah, yeah.
right? So just like that, we in AC in APIC when we bring up the APIC at the from hardware level, at that time there is this option that we have to define the pool. Here we have selected 10.0.120.0/24 or whatever the range that is. So it will automatically assign one available IP to each of the spine. This will be my management IP. This will be my everything IP for that leaf or spine. Okay, for the in the fabric. So this is automatically assigned by APIC. APIC controls the assignment of the IPs to leaf and spine. Hope that answers your question.
No, that is not my question. Actually,
Okay.
my question is like, so
Mm-hmm.
in Epic, I saw mostly that 10 dot series IP. So can we change that IP subnet, or it is just reserved for that Epic, ACI Epic?
So yeah, there is some consideration actually. You can so it's fine. You don't need to have 10 only. You can change it, but the subnet range, there is a specific subnet range like from 16 to slash 16 to I think slash 22.
Yeah.
This much of minimum subnet you need to keep available or you need to reserve for this internal APIC DSCP assignment. Okay, so yep, you can do it. You can do
Okay.
it.
Got
Okay.
it.
So now I'll hand over to Sajid from Network Journey, and he will take you through all the details. Over to you, Sajid.
Yeah, thank you. Uh, Let me share my screen. Hello, everyone. Myself, Sajid.
Yes, sir.
I'm a student relationship manager and the counselor. So I'm here to give you details regarding this course enrollment. And here I'll be giving over the like details what all you'll be getting while you are going to enroll and all with the other things. In case if anyone is enrolled, so you guys can drop off if you have to go on. Okay. So I'll be giving for the remaining persons. If you want to stay, you can stay. Okay. So let me start with my first slide. As you can see here, can you guys see my screen?
Yes.
Yeah, thank you for confirmation. So as you can see here on the screen, I have mentioned course syllabus and class schedule. So here, this will be going to be a total SDN orchestration course, which is called as. And here we'll be covering total three major modules of this SDN orchestration course, which covers Cisco ACI, Cisco Nexus, and Cisco SD-WAN. So these three will be taken, and Cisco ACI will be taken from the trainer Samin, so is expert in the ACI, DC ACI, and the Cisco Nexus will be taken by other expert trainer, and SD-WAN will be also taken by the same person who is going to take the Nexus. The person who has the expertise in that dedicated model, so he'll be going to take the particular Nexus or SD-WAN or ACI. Okay. So here, let me mention you I have mentioned for class schedule. So this will be going to be a weekend batch, Saturday and Sunday from 7 p.m. to 9 p.m. IST every weekend, Saturday and Sunday, 2 hours of session. And for overall SDN orchestrations, it will be going to be a total 4 months of course duration. And if you're going for standalone Cisco ESA or Cisco SD-WAN, so that will be completed by in 2 months. 2 months will be the course duration for standalone any module. Okay. And let me move towards my next slide. So as you guys can see here, so I have mentioned details for what all access you'll be getting once you are going to enroll for this course. So you'll be getting the lifetime recording access of your classes, which will be attending through the Zoom meeting. So the lectures will be recorded into the cloud and that will be getting uploaded to the our LMS web portal. From there, you can access the class recordings whenever you want. And in case if you are preparing for your interviews or for your recalling thing, or it may be related to your production work, whatever it may be, like you can have the access on the web portal whenever you want. You can go through the recordings. And in case if you missed out any particular session for the particular day, so the recordings will be available in the portal in meantime of 1 to 2 hours, so that if in case if you missed out, so you can go through the recording and you can catch up for the tomorrow's class. And in that session, so if you have any doubts or anything, you can clear it with the trainer and you can be in the sync with the actual flow which is going on. Okay. And secondly, we'll be providing you the 24/7 remote lab access, that you can access it totally remotely, 24/7 unlimited. Whenever you want, you can access the labs which are present on our servers and cloud servers. Okay. And we'll be providing you the 3 months of remote lab access for each module. For Cisco ACI, 3 months you'll be getting lab access for your Cisco Nexus, and for your Cisco SD-WAN, three months of each lab access you'll be getting. And we'll be providing you the dedicated materials like workbooks, PPTs, PDFs, step-by-step lab manuals, all the reading materials, everything will be providing you, that you can download and you can keep it with you as well. If in case if you missed out any material, you can re-download it once again. Okay, and the G Drive access remains with you for lifetime. And let's say if you have the good configuration of your system, then we'll be helping you to set up a home lab, so that once you are done with your remote lab access, further you can practice on your personal laptop. And that will also remain with you for lifetime accessible till when you will keep on your system. So till that you'll be having that access. And basically for this, you should have the very good configuration of your RAM and CPU core, and some good storage available on your system. It may be on your personal server. So we'll be helping you to set up a lab. And we'll be providing you the 24/7 backend support from our team. If you are facing any issues, any queries regarding to the course or regarding to the portal or regarding to the lab, anything it may be, you just need to raise a ticket on our support DL. One of our team member will connect with you and we will resolve your issues accordingly in meantime. Okay. So these all were access given by from our side. So you'll be getting all the access once upon the enrollment. Okay.